Hello, everyone. Welcome to the Gerhard Center. This is a webinar series. This is the number 100 plus 1, so 101. But we're calling it Gerhard Center 100 plus. And we're going to shift away from the COVID-19. We're going to start focusing more on sustainability and social impact. Sustainability because of COP27, of course. Now, the topic of the 101 is about climate change. Interestingly enough, there are still people debating whether climate change is a fact or is it whatever. And I was talking with Youssef about this, and his expression is a flat earth versus round earth kind of a discussion, because there is strong scientific evidence that it is happening. There is also strong scientific evidence that Earth, the whole ecosystem, is very vulnerable for it. Now, I talked with Youssef, and we ended up having two brilliant speakers, and I'm going to pass it to Youssef to sort of introduce them. But again, I mean, the focus today is on the state of science and evidence of the existential risk posed by climate change and the transformation imperative, the link to impact, vulnerability, and adaptation. Now, Gerhard Center and the webinar series has long relation with Youssef, and the business school at the AUC. Youssef was with us in March 15th on the business forum when we had a panel discussion about just transition. And also he was with us in June 9th on COP27 and the role of African universities. Youssef is the director of the Adaptation Division at UNFCCC. Without much ado, I'll pass it to Youssef, and I'd like to thank him and thank our two ladies who are guest speakers for us. Please, Youssef, the floor is yours.
Thank you very much. Thank you, Ali. It's a great pleasure to be back in one of your webinars. And yes, we have two very distinguished speakers with us who I will introduce in a minute. I see a lot of very good friends in the participants list, and I see it growing as we are speaking. Special shout out to Dr. Salah Harafa, who was actually my professor when I was a physics student back at AUC. The topic today is really about the interface between science and policy and the interplay between them. Having been part of the international climate change negotiations since the 90s, I've seen how the successive advances in science and the evolution of certainty in the science of climate change have greatly influenced policy and have been actually direct catalysts in quantum evolution of the climate change process and the legal instruments coming out of it. So today we're discussing the state of this science and the new phase we're in. I think beyond how certain we are about climate science, etc., and the debates and the flat earth and the round earth story, I think that we've entered into three phases, in my view, of the evolution of the mindset towards climate change. The first one was a purely environmental one. So in the 90s, we were seeing this as, something in one of those environmental corners together with biodiversity, etc. Even in the negotiations, most of the people who would come to these negotiations were from environment agencies or meteorological agencies. Then we got into the developmental mindset where we're saying, oh, this is a development issue. Climate change is all about development. It was the Millennium Development Goals phase in the 2000s. And we're trying to quantify everything, ecosystem services, etc. But since, I think, 2018 and 2019, the science came up with us with two reports, one from the climate change side and one for the biodiversity side, saying basically the same thing, that you have a decade in which to transform. And this, I think, brought us into a very different mindset. It's the existential mindset, that climate change is no longer something that is affecting a little corner there, that environmental corner. It's no longer something that just affects our capacity to become more wealthy or more developed, but now it's an existential risk, which means that if we don't tackle it seriously, we may lose a lot in terms of prosperity, in terms of growth, but also in terms of our capacity to continue as a human race. And it's not very easy for a normal person on the street to visualize this, because we wake up today, it looks exactly like yesterday. You wake up tomorrow, it looks like today. But then you have to know that there are also tipping points. You might wake up tomorrow and find something that has completely transformed, or also gradual changes, which reminds us of the story of the frog that you throw in boiling water, it jumps out at all. But if you throw in slowly increasing temperature, it stays there till it dies. And I think if you've watched that movie recently, Don't Look Up, I think it portrays exactly how the landscape of decision making on climate change at the national level, at the international level, works. So that has called for a transformation. The IPCC, the Intergovernmental Panel on Climate Change, which is the consensus, the scientific consensus on this matter, including scientists from all over the world, has asked for a large-scale transformation in human societies. And we'd like to unpack this. So as we transform towards climate neutrality, meaning reducing greenhouse gas emissions to a net zero, and also to resilience, where societies are resilient and adapted enough to be able to counter any adverse effects of climate change. What does this mean? What does it mean for political systems or social environments or economies or technology? And are we talking about systemic change, or are we talking about a more drastic paradigmatic change? And where does climate justice fit there? Equity, inequity, just transition. When you do a transformation, there are usually winners and losers. How do we deal with this? How does this work at different levels? The transformation, is there a global side to it, and there's a national side to it, and a subnational side to it? So there's a lot of detail there, even at the conceptual level, let alone as this is implemented in terms of policy, that the world has to grapple with. And it's really difficult from the side of international politics, where we are used to incremental change, not transformative change, because you need consensus of the whole world to take any decision. This contributes to adding to the body of international law. And it's really the science that is the catalyst for pushing the politics. It enables and empowers policymakers to take these drastic decisions of transforming bit by bit the systems in which we operate. And so we have today, to help us decipher some of this, two amazing speakers, as I said. One is Valérie Masson-Delmotte, who's the co-chair of Working Group 1 of the Intergovernmental Panel on Climate Change, which is the working group on science. And she's also a senior scientist in France's Laboratory of Climate and Environment Sciences of Institut Pierre-Simon Laplace at the University of Paris-Saclay. She's trained in fluid physics, has an extensive research background on tons of issues, including quantifying and understanding climate and water cycle variability, climate information from ice cores, climate response to natural and anthropogenic forcings, climate feedback, abrupt climate change, ice sheets, sea level, has 250 peer-reviewed publications, and is one of the most highly cited scientists in the field of geosciences since 2014. So we're really privileged to have Valérie with us, and thank you very much for being here. Now, my very good friend Zita Sebesvari, is the Deputy Director of the United Nations University Institute for Environment and Human Security here in Bonn. We are both located here. And Zita also heads the academic section of that institute on environmental vulnerability and ecosystem services. She's an internationally recognized expert in the fields of social ecological risk assessments, ecosystem-based disaster risk reduction, and ecosystem-based adaptation, with a focus on low-lying coastal areas like river deltas. She's an ecologist by training and holds a PhD in environmental science from the Karl von Ossietzky University in Oldenburg in Germany, and is the author or co-author of around 70 publications, and is also affiliated with the Intergovernmental Panel on Climate Change, where she was a lead author in the special report on ocean and the cryosphere. So welcome to both of you. And I just like to reiterate our sincere gratitude that you've accepted to be here and share with us your amazing insights and experience on this interplay between science and policy, and how it can get us to look a bit differently about climate change, especially that we have quite an amazing set of participants here who may not be climate experts, but are intellectuals, and very much looking forward to hearing what you have to offer. So I'll start with Valérie, who will explain to us the underlying science, the information available, the futures, the different futures that we're looking at, especially through that transformation, and basically what does it take to attain these futures, followed by Zita. So we start with you, Valérie. Please go ahead.
Thank you very much, and I'm really glad to be able to join this webinar. So this presentation will be focused on a body of evidence, which is the outcome of the assessment of 14,000 scientific publications, the work of more than 200 authors, 600 contributors, authors from 65 countries, and a work that has been heavily reviewed, 2 rounds of review by the scientific community and experts nominated by governments, leading papers that have been approved word by word, line by line, by delegates from all governments, to ensure that these key findings are clear and provide a balanced view of the current state of knowledge. When I'm talking about the physical science basis, we build on multiple lines of evidence, insights from past climates, insights from observations in every component of the climate system, the atmosphere, ocean, land surface, the frozen parts, the cryosphere, and from space, the understanding of processes that can be physical, chemical, and biological, affecting the carbon cycle and the climate system. And we use global and regional models. We also build from developments in climate services that co-produce climate information that is actionable and relevant for users. So the report is fully available from the IPCC website, and I'll focus on some of the key findings. And just to express the fact that it's part of a whole set of IPCC reports, 3 special reports highlighting how much every increment of warming matters, how much we are connected with the ocean and cryosphere everywhere, for instance, through sea level rise in a place like Egypt. So the cascading effects between changes in the physical system, ecosystems, and societies, and the issue of building resilience, and climate change and land, and an emphasis on food security as a major aspect related to climate change. So I'm going to focus on the physical science basis, but there's also a wealth of information on transformations to integrate adapting to a changing climate and reducing greenhouse gas emissions, mitigating climate change. I'll just provide the physical science perspective on that. And by March next year, we'll release a synthesis report building on the whole wealth of information. So the first important message is that recent changes in the climate system are widespread, rapid, intensifying, and unprecedented in thousands of years. And if we focus on one indicator amongst many of the state of climate system, we're going to look at the level of global surface temperature change, so above land and in the ocean, averaged at the global scale compared to the late 19th century. So this is a critical indicator of the state of the climate. And as you can see, when we take the late 19th century as a reference, we observe from all available data sets average a warming that is unequivocal and that is reaching for the last 10 years 1.1 degrees Celsius above the pre-industrial conditions. That warming is largest in the Arctic and much larger over land in Egypt, for instance, than the global average. And at the global scale, the warming we are currently experiencing is unprecedented in more than 2,000 years that is documented by work from historical sources and natural climate archives. In order to understand what is driving this warming, we consider every possible process. We consider internal climate variability associated with movements in the ocean, the atmosphere, their interactions. But because this only redistributes heat, this cannot explain an accumulation of heat in the climate system which is observed, not just in the atmosphere, but also through the warming of the soils, the heating of the global ocean, and the melt of the cryosphere. We also account for the variability in solar activity cycles. We also take into account here and then major volcanic eruptions, their particles, and their temporary cooling effect. We also account for human effects, changes in land use, emissions of pollution particles that have a cooling effect through a sort of umbrella effect, and emissions of greenhouse gases that have long been known to have a warming effect. When we account for each factor, our conclusion is very clear. None of the natural processes can physically explain the warming to date. And when we account for human-induced changes to the Earth's energy budget, our best estimate is that all of the warming to date that is observed is the outcome of human influence on climate, with warming from greenhouse gases partly counteracted by cooling due to pollution particles. So now human influence on climate is unequivocal. And we have even a better understanding of the role of every driver. The warming to date has as a first driver our emissions of carbon dioxide linked to the burning of coal, oil, gas, linked to deforestation or cement production. The second main driver is associated with leakages of methane to the atmosphere. And recently, methane emissions have been driven mostly by leaks from the fossil fuel industry, as well as the increased livestock globally. Carbon dioxide interacts with photosynthesis, respiration, leads to acidification of the ocean. So it has a specific role, not just on climate, but also on life in the ocean and life over land. Methane is a powerful but short-lived greenhouse gas. It stays only around 10 years after being emitted in the atmosphere. It alters atmospheric chemistry, leading to ozone production, which is a pollutant and a greenhouse gas. So human influence on climate is unequivocal, and it's the main driver of warming. It's also the main driver of an increase in water vapor in the air, because a warmer air can hold more moisture. It contributes to shifts in atmospheric circulation that, for instance, lead to a decrease of precipitation in all lands around the Mediterranean Sea. Human influence on climate is the main driver of the loss of Arctic sea ice, the retreat of glaciers globally. It contributes to, for instance, the melting of the Greenland ice sheet. And because that water was stored over land in glaciers and ice sheets and is now reaching the ocean, it contributes to sea level rise, together with the fact that ocean absorbs around 90% of the excess heat that does not escape back to space because of more greenhouse gas effect. And one indicator of the state of the climate system is also sea level rise, 20 more centimeters since 1900, accelerating pace because ocean heat uptake, glacier melt adds to an increased loss of ice from the Greenland and Antarctic ice sheets. And over land, the human influence on climate affects the global water cycle with an intensification, and it also affects the growing season, for instance, for plants. Climate change, it's already affecting every region on Earth, over land, in the ocean, from the high mountains to the deep ocean, from the poles to the tropics in multiple ways. Trends in temperature, trends in precipitation, sea level rise, but also more frequent and more severe heat waves, heavy rainfall, and drought events. Here you see that in every continent, we have evidence for the intensification of these hot extremes. Every red hexagon Med is the surrounding of the Mediterranean area, including Egypt. And the dots indicate our level of confidence for how human activities contribute to extreme heat. Many hot extreme recently would have been extremely unlikely to occur without human influence on climate. And we can even quantify how much more warming results from that. We also observe an increase in heavy rainfall events, which is contrasted around the Mediterranean area, depending on the place, but quite clear in all the areas appearing here in green. And because a warmer air can hold 7% more moisture per degree of warming, a direct consequence of warmer conditions is the possibility for a given storm to lead to heavier rainfall amounts. And in areas that appear here in yellow, this is where we observe an intensification of soil moisture drought. This signal is strongest in areas with a Mediterranean type climate, including North Africa. And this is the result of a shift in atmospheric circulation, leading to less rainfall, together with hotter air conditions, stimulating more evaporation, more transpiration, and emptying the soils faster from their humidity. Human-induced climate change also leads to more intense fire weather conditions over longer seasons and larger areas. The effect of extreme heat or runoff from heavy rainfall is exacerbated by urbanization in cities due to cities' heat island effects or a faster runoff over impermeable surfaces. And we observe major damages for ecosystems worldwide, including tree mortalities, for instance, or coral dieback as a result of extreme heat over land or in the ocean. Half of the studied species in the ocean and over land are shifting to just adjust to their usual habitats. Looking now towards the future, future climate change will depend on future emissions. And considering the Paris Agreement goals linked to serious risk considerations, including habitability, it is quite striking from the physical science perspective that unless there are immediate and large-scale reductions in greenhouse gas emissions, limiting warming close to 1.5 degrees Celsius or well below 2 degrees will soon be beyond reach. And this conclusion is established by understanding the climate response to a broad range of scenarios that illustrate the full range of hundreds of scenarios available in the socioeconomic literature, exploring different development pathways and their outcomes in terms of greenhouse gas emissions, here illustrated for carbon dioxide. So scenarios assuming no further climate change mitigation and high or very high use of fossil fuels and greenhouse gas emissions. An example intermediate scenario that is consistent with current policies and their implications without further climate ambition. And then scenarios that imply much faster action to reduce greenhouse gas emissions than currently planned. And these two lower emission trajectories are associated with reaching globally net zero CO2 emissions resulting from human activities by around 2050 here or around 2070 in the other scenarios. So we analyze the outcome of all available climate models in the world and their temperature projections are constrained by observations and by our understanding of the climate response, building on multiple lines of evidence, what we learn from past climates, what we learn from observations, and what we learn from constraints on each feedback loop, including typically clouds. And by this approach, we have narrowed by about a factor of 2 the range of uncertainty of the climate response through temperature to a given scenario. So what do we expect? This is where we are now, the 1.1 degree of warming to date. In the near term, by the next 20 years, across all scenarios, we expect the level of global surface temperature to reach or surpass 1.5 degrees Celsius. By 2050, we show that with current policies, a level of warming of 2 degrees could be surpassed, but it could be avoided with low or very low greenhouse gas emissions and major reductions in emissions starting in the coming years and amplified through time. For an intermediate scenario, I report here our uncertainty range by the end of the century. So you can see that our uncertainty range varies from 2 to 3.5 degrees Celsius. So now we cannot completely rule out reaching a level of warming of something like 4 degrees, either in the case of high emissions or in the case of a temperature response in the upper tail of what is currently physically plausible. But this is not the most plausible outlook. The changes that we experience currently will increase with every further increment of warming. So this is illustrated here for different levels of projected warming, 1.5, 2, or 4 degrees above pre-industrial. What would be the trends in average annual mean temperature across world's regions? And you can see with a higher level of global warming, temperature trends increase in every region, and again, faster over land than the global average. When we look at changes in annual mean precipitation, you can see contrasted changes, an increase in annual mean precipitation in cold regions, some increase in monsoon regions associated with contrasted effects of greenhouse gases that lead to a wettening, and local pollution particles that can lead to a drying. And around the Mediterranean Sea, in South America, South Africa, areas of Australia, a decrease in annual mean precipitation that increases with further increments of global warming. And this leads, in fact, to a decrease in soil moisture, which is critical for plant growth, agricultural activities, and will lead to further aridification directly related to the level of warming. So the level of global warming matters because it's directly connected to an increase in the frequency and intensity of hot extremes, marine heat waves, heavy precipitation, droughts in those drying regions. In the tropics, it's also directly linked to an increased proportion of the most intense tropical cyclones, cryosphere reductions in cold regions, and an intensification of the water cycle and its variability, which means more severe, very wet and very dry seasons and events, longer periods without rainfall, and more intense rainfall concentrated in a very short amount of time. So it is really crucial to use our knowledge of future regional climate change to prepare for new types of events, to enhance adaptation, not just looking backwards at events that have already occurred, but new types of events, new compound events that will occur without insights from past experience in many regions. There's no going back for some changes in the climate system. The amount of heat accumulated in the deep ocean, this is related to a time scale of hundreds of years. Glaciers will continue to adjust to today's climate over decades, losing mass, and the time scale of the adjustment for the Greenland or the Antarctic ice sheet is hundreds to thousands of years. As a result, sea level rise is committed already from past emissions and will further increase with emissions to come. So if we look at the projections for sea level rise, we've already had about 20 centimeters rise. We expect about 20 centimeters rise in the next 30 years, rather independently of the emission scenarios. By the end of this century, you can see that the magnitude of sea level rise increases by a factor of 2 between a scenario with very, very low greenhouse gas emissions and a scenario with very high greenhouse gas emissions. And if ice sheet instabilities are triggered, fast flow of some unstable sectors of Antarctica, then you can see that the magnitude of sea level rise could double this century. This is a possibility associated with deep uncertainty. It's not the most plausible outlook, but this is the type of information that managers of critical coastal infrastructure, harbors, industrial areas, cities, critical industry require so that they can also prepare for a plausible worst case scenario. And sea level rise continues over hundreds to thousands of years. So this is part of the heritage of our legacy on the very long term, with major sustainability issues for coastlines worldwide. This is going to drive increased chronic high tide flooding in the coming years, more extreme sea level events during storms, increased sandy coast erosions, and loss of habitability for low-lying areas, including large deltas. So in our report, we build on our physics knowledge to identify the combination, the types of events that are known to drive impacts. And we provide 33 of these impact drivers that can be used to inform adaptation strategies in various sectors. What really matters is to understand that for most world's regions, there will be 10 to 15 of these characteristics, mean values, seasonal changes, extremes, that will change at the same time in the coming decades. So this information, we make it available, our assessed data sets, through an interactive atlas where you can yourself navigate for your region of interest through levels of warming, emission scenarios, or time horizons. We also have an atlas with NASA for sea level projections at the regional scale. And here it is shown for the city of Alexandria in Egypt as the year by which an increase of sea level of 0.5 meter above today is expected. And this depends on the occurrence of ice sheet instability and the greenhouse gas emission scenarios. With less global greenhouse gas emissions, this happens later, typically next century. With more greenhouse gas emissions, larger warming, larger sea level rise, this would happen in the second half of this century. So this is the type of information accounting for the uncertainties of what the world is going to do for greenhouse gas emissions can be used to inform coastal sustainability strategies and responses. And finally, climate physics shows how global warming could be stopped and everything that depends on global warming, and how we can limit the pace of what is unavoidable, such as sea level rise. So to limit warming, what matters most is the cumulative amount of CO2 released into the atmosphere. So this is cumulative emissions since 1850 at the global scale, and this direct relationship with the amount of peak warming between now and 2050. So this is really important. It's the outcome of the compensation of complex processes that lead to this linear relationship. First thing, when we reach net zero CO2 emissions, there's almost no more warming in the pipeline. the inertia does not come from the climate system. It comes from the existing infrastructure, from the thermal power plants that exist, those that are planned, that are associated with the lockdown of emissions over the lifetime. But if we manage to transform, in particular, the energy system, but not only, then if we manage to reduce emissions, we slow down warming, and only when net zero CO2 emissions are reached would warming stop. So this is really critical. Over the long term, cumulative CO2 emissions need to stop increasing to limit global warming. We also need large reductions in other greenhouse gas emissions, and there's a specific benefit associated with methane mitigation, because pollution particles that are short-lived have a cooling effect, are emitted when we burn fossil fuels. So decarbonization leads to reducing CO2 emissions and a loss of the cooling effect of pollution particles. To counteract that, strongly reducing methane emissions, typically a third this decade, could counterbalance the loss of the cooling effect of pollution particles, limit peak warming in the near term, and because methane affects atmospheric chemistry and the production of ozone that is toxic for our health, it would also further improve air quality with major benefits for public health. If we act strongly, when would we see that? What is the difference between the outcome of the scenarios with high and low CO2 emissions? For changes in atmospheric concentrations, a few years, quickly for air quality as well. But we would be able to see the slowdown in the rate of global surface temperature within around 20 years. So that's about the time when we could observe the outcome of ambitious mitigation. So to conclude, limiting global warming, it has geophysical constraints on how to do it, and the remaining carbon budgets are a clear outcome of the physical science understanding of the climate system and carbon cycle. Limiting global warming reduces consequences of climate change that have serious effects on societies and natural systems. This is further illustrated here by, for every continent, the number of days associated with dangerous heat that strongly increases first in the tropics and then in the intermediate latitudes with further level of global warming. So heat that is dangerous for physical activity and health. And it also allows to limit the increased hazards resulting from extreme rainfall that escalates, in fact, with every further increment of global warming and affecting other regions. So to conclude, we show how much the climate we experience in the future depends on our decisions now, in particular for greenhouse gas emissions, but also that climate information can be used to better prepare and to enhance resilience for what is unavoidable in the coming decades. And the report provides you a wealth of further information, fully traceable to the evidence and to the source of peer-reviewed publications supporting these few key findings. Thank you.
Thank you very much, Valérie. And this report is what feeds into the international policy process and drives our change in ambition. So indeed, future climate depends on our decisions now. We've seen from Valérie's presentation how human activity has already led to unprecedented warming, and how the SSPs, the shared socioeconomic pathways, shows that we can take choices that can either land us in the worst possible scenario, a really undesirable world, but we can also take choices that can land us in that desirable world. So there's a political will aspect there. But also that a lot of this is really uncharted territory. Even when we think we understand things, the reality can totally exceed our expectations. I remember in the 2011 floods in Bangkok, right before they happened, I just read a report from the Asian Development Bank outlining what the impacts would be of a massive flood in Bangkok. But then when it happened, it was so different. No one had predicted that the crocodiles would escape from their reservoirs, and the rodents would spread the diseases that they did. And there were so many different things, and you realize that small decisions in which parts to decide to flood versus protect made a huge difference in how this panned out. Whereas you know, from just reading a death study, you'd imagine it would work differently. And so the need to transform this decade is not really an exaggeration, because each small decision in the present can lead to an enhanced outcome in the future. Now, we know if we reduce emissions to zero today, we will still have locked into climate impacts, and we still need to adapt to these impacts. Valérie, I think, talked about the impact on the city of Alexandria in Egypt, and recently in the report from Egypt called the Nationally Determined Contribution, the report to the UNFCCC, they mentioned there's a risk of losing 8.2% of the agricultural land of Egypt as early as 2030 due to climate change, and an associated 30% of food production. And like I said, again, reality might exceed this estimate, because there are a million other factors beyond climate change and secondary impacts, and a lot of non-linear relationships that can make this a really dire scenario. And while we're talking now about impacts, vulnerability, and adaptation, it is time to listen to our second prominent speaker, Dr. Zita Sebesvari. I've already introduced her and her bio in the beginning, and Zita will talk to us more about that context of impacts of climate change and adapting to it, and it's relevant to that context of transformation that we've been talking about. So Zita, please go ahead.
Thank you, Youssef. So sharing my slides. I hope you can see it. So I selected the title Adaptation in an Interconnected World. And I will present you some interconnectivities actually which can help or hinder us to leverage a profound change. And of course, I will explain what I mean with that. On the first slide, I just bring you some of the key messages of the IPCC AR6 Working Group 2 report, which is looking into vulnerability and adaptation. So there's a huge number, more than 3 billion people who are living actually in hotspots areas with high vulnerabilities to climate change and their increasing impacts. And it is very clear from Valérie's presentation that action on adaptation is needed, even if it would stop emissions right now. What we see in the scientific literature and also in gray literature and on the ground, that actually there's an increasing implementation of adaptation action in different fields. And the IPCC report actually brings together the evidence on that adaptation, which is already ongoing. But it also states that progress is uneven. So in some regions, taking more adaptation action place than in others. And clearly we are not adapting fast enough, which we can witness in terms of the impacts we are seeing related to climate-driven severe weather events and their impacts on our life, agriculture, infrastructure, and so on. There's also an increasing gap between the adaptation needed and what is actually happening, which is expressed by the statement that we are not fast enough. So since emissions are still growing and the impacts are increasing, the adaptation action on the ground is not keeping pace currently. I would like to draw your attention to one key figure in the IPCC report and the so-called summary for policymakers, which brings, so to say, the main messages in a short, condensed format. So what you see here is a new understanding of interconnections between our social and ecosystem, and how they actually interact with the climate system, how they are mutual interactions and feedback loops. And since I am an ecologist and coming from that ecosystem background, I'm actually very happy that the 6th assessment report has put a much stronger focus also on ecosystems, so how ecosystems are actually impacted by climate change, how they could be means of adaptation, and how they could actually help us to adapt and to mitigate, and what are the trade-offs. So if you are thinking about mitigation efforts based on land, like afforestation or reforestation efforts, how to do that actually in a way that it's not harmful for biodiversity goals, and that we are not going for large-scale monoculture, which is then fixing some of the much needed CO2 fixing, carbon fixing, but at the same time, so to say, harming biodiversity objectives. One of the key messages of the 6th assessment report is also that we see increasingly that extreme events compound with each other. For example, heat happening together with drought, and oftentimes even with fire. And that not only this hazard combines with each other, but also climate change impacts combine with all the other important processes, such as development aspirations and their consequences, like habitat destruction, so loss of ecosystems, or losing healthy ecosystems, but also unsustainable use of natural resources like water, sand, metals, and so on, growing urbanization, and global but also local inequities. And this is where I would like to bring you some examples. I prepared 3 examples which highlight how habitat destruction, unsustainable use of natural resources, growing urbanization, and inequity actually interact with adaptation needs and adaptation action, and how they need to be taken together when we are doing decisions, and we are, so to say, trying to transform our life and society in order to be able to deal with the consequences of climate change. So the first example I am bringing, and I deliberately selected examples which are, how to say, a bit of a surprise. So probably you wouldn't have thought about these examples when you are thinking about climate change and adaptation to the impacts. So the first example are the wandering elephants in China, which some of you may have heard about in 2021. They were very prominent in the news. It's a herd of 15 elephants, which left their territory in southern China, and who walked about 500 kilometers within China. They were reported in different media, in the television and newspapers, because it was quite unusual. So they walked around 500 kilometers, and they walked towards Kunming, which was actually the place where the Conference of the Parties for the Convention on Biodiversity should have taken place. So the wandering elephants raised a lot of attention, and of course we can't interview the elephants why they left their space, but if you look into the data and if you look into the circumstances, this is what we see. So they left their habitat in March 2020, and at that time, there was a prolonged and severe drought in the area for around a year. So there was a lack of access to water and also food scarcity. This combined with the fact that actually there was a big success of elephant conservation. So the number of elephants raised in the last 50 years in the area, but at the same time, the space which is suitable for elephants decreased strongly. For example, by rubber plantations, rubber needed for livelihoods, but also for export and for satisfying global demand pressures. And this is something we are seeing with climate change increasingly, that animals actually changing either their range, so the area where they occur, or they are changing their behavior in case of a drought or a flood event, or driven by climate change. So there are studies showing that climate change is actually driving human-wildlife conflicts, which relates to resource scarcity, the impacts of severe weather events, and also land use changes. Altogether, the elephant shows that when we are thinking about adaptation, in this case, for example, to drought and the increasing frequency and severity, we not only need to think about agriculture, but also about ecosystems, about habitat and wildlife, and how to protect them, and also adapt in a way that they have a chance to adapt. And if we don't do that, this has an impact also on our society. So the elephants needs around 150 kg food per day. So 15 elephants in one agricultural field, you can then count what remains. So along their 500-kilometer tour, they caused around $1 million damage, and luckily there were no fatalities in terms of deadly outcomes. But altogether, we need to reshape our relationship to nature. We need to see ourselves, humans, as part of nature, and not trying to tame it and put it into boundaries. So with that, I would go to my second example, which is an example about climate change impacts coinciding, interacting with unsustainable use of natural resources. So what you see here is flooding in Lagos, Nigeria, which happened last year as an outcome of a heavy rainfall event, which is predicted to increasingly happen in the future in Lagos with climate change. And what you are seeing on the right corner of the picture is a man who is mining sand from the shoreline, from the beach, but also from the near coast shoreline. And the way how these both things interact is, you remember that Valérie talked about sea level rise. And Valérie talked about global mean sea level rise, which needs to be then specified for each and every coastal reach and city in a more, so to say, localized way, because many of our coastlines are actually sinking, which we call subsidence. And that sinking is happening, so it might have geological reasons, but in many cases it's driven by anthropogenic activities, so our decisions and our actions. One of the main causes is extraction of groundwater, so that with extracting groundwater, the land is compacting and sinking. But also, if you put an increasing number of large buildings on the shoreline, that's also cause compacting and sinking. So in case of Lagos, but Lagos is not alone there. Jakarta, Tokyo, many other places are sinking too. So in case of Lagos, sinking is quite severe. You have in some places of the city 87 millimeter per year. That means that this subsidence contributes to sea level rise, and the relative sea level rise in the area is significant. If you combine this with heavy rainfalls and with the extraction of sand from the shoreline, which means that you are removing your natural barriers, you are removing the shoreline, you are removing sand dunes, and with that, you are kind of opening the sluice for even more seawater to intrude the city, the lagoon, and then later on also the inland. So that combination of unsustainable resource use and sea level rise paints a quite severe picture for Lagos, for example. And the big picture is that it's not only Lagos, so there are many the coastal cities sinking, and there's also a huge global demand for sand. So right after water, this is actually the second most sourced resource globally, and this is largely flying under the radar. So there's not too much attention paid to sand, and many of the adaptation suggestions along the shoreline, so how to deal with increasing sea levels, actually uses sand to solve the problem. Like if we are thinking about build a seawall or build barrier islands, or like all this needs sand, which is getting scarce. And sand, which is to be found in deserts, is not suitable for construction. So it's really the sand from the shorelines and from rivers, which is sourced for construction work. So moving to my last example, I'm bringing you now to New York City, which was hit last year by Hurricane Ida, which caused a large amount of heavy rainfall within a short period of time, and actually triggered New York City's first ever flash flood alert. It was severe, and the infrastructure couldn't deal with the amount of water at all. So you hear people paddling. It was the most expensive disaster in last year, with a record rainfall. The aging infrastructure couldn't deal with it, and they have been in the city itself 13 fatalities. Out of it, 11 hit people in basement apartments, which are usually unregulated and mainly frequented by immigrants. And this is where I'm bringing, so to say, together an example of urbanization, but also inequity issues. So urbanization, large urban structures are difficult to reimagine and to rebuild, because there is a lot of locked-in infrastructure, so a lot of built infrastructure which is not easy to change and very expensive if you are thinking about reimagining New York City's infrastructure, also in context of sea level rise, but also in context of heavy rainfalls. It's incredibly expensive. But at the same time, if a hurricane hit New York City, because of the huge amount of assets, economic concentration, it also leads to a huge amount of damage, right? But at the same time, the example also shows that even in developed context, many times it's the disadvantaged and the vulnerable which are hit hardest, and many times plans and also future planning is not really focusing on the vulnerable and those who needs the help most. So there is a need to reimagine our cities, and we need positive visions how those cities could look like. So it's not just the money is lacking, but I think also the positive visioning how they should look like in the future. If you would like to look into more examples, you could visit our interconnected risk report, which we published 3 weeks ago. So it's quite new, and it comes with 10 interconnected case studies. And now going back to the IPCC 6 report, these figures are quite instrumental when we are thinking about future trajectories and potential decision points. So what you see here in the middle, there's a blue dot. This is where we are today. You can see that some of the options we already missed to take. This you see this dotted yellow greenish line at the top end. So those options are not available anymore. But today we can still make good choices, which would bring us on the green path or the yellow path, which would allow us to build sustainable futures. But we can, of course, also miss action and just continue as we do. And then we are ending up at the climate change impact, which Valérie, so to say, provided us as science-based facts. So given also the limits of adaptation in certain future scenarios, it's really essential to make rapid, immediate, and deep cuts in greenhouse gas emissions. And with that, we would also keep the maximum number of adaptation options still open. And I'm bringing you from the Conference of the Parties, which took place in Glasgow last year, from a cartoon gallery, one cartoon which shows this guy on the horse in his dilemma. But if it goes the other way, I will have gotten off my horse for nothing. And I think this shows, so to say, our dilemma, how actually make this guy acting. And one of the messages I would like to convey that facts and knowledge is one thing, but the heart is another one. So how to make this guy thinking with his heart on this person lying there and wanting to save her. How do we get this guy down from his horse, and how do we get him actually acting and saving the lady, or in our case, the planet in a way. I would like to show you one a figure which is from the transformation research background. So it's a busy figure, but I will take you through. So what you see here in the middle, there's the so-called dominant socio-technical regime. So you have here markets, industry, policy, technology, science, and culture acting in a certain way. In our case, business as usual, which is generating further climate change. So what you see at the bottom of the picture is kind of the niche level. So the ideas, initiatives, aspirations, which would possibly bring us to a different track. And but the figure explains how from this niche level you can get actually into the mainstream level. You can influence the mainstream level. Additionally, the mainstream level could be influenced also by sudden changes. If you just think of in the last 2.5 years, I would say such a sudden event was the pandemics. It's changed radically for some months at least how we used transportation, how we acted, how we interacted with each other. And those sudden events can contribute also to a regime change. But we do not need to wait for those sudden events. Also, the niche level can get powerful and be able to change the main regime. This slide shows how so to say, from the niche player, you can reach people who are setting agenda, who are leading opinions, and those who lead opinions can influence the mainstream. And we actually reached our goal when the mainstream looks back and looks at the actions they have been taken in the past and thinks, wow, how could we do that? How that was acceptable in the past at all? And then I think this change, you can see it in the past in several changes which happen. And once the society reached that, this is where the new behavior basically stabilizes. And this is not easy, but everyone who knows that we need to act, need to join basically in together to get there as a society. And with that, I would like to close. Thank you very much for your attention.
Thank you very much, Zita. That was an incredible and sobering reminder, both on climate impacts, but also, again, on the choices that that we can make today in order to either produce a desirable or an undesirable world, and also on the chances we missed already by locking into the wrong choices. And we saw examples from real life, from China, Nigeria, and the United States, and how we continue doing the wrong thing by applying the theory of sunk cost, that we can't stop doing the wrong thing since we've invested so much in it, as is shown by the cartoon of the guy on the horse as well. And your final couple of slides on transformation, which reminds us of Joseph Schumpeter's theory of creative destruction, how you can have these impetuses that can then change the paradigm. So now we'll open the floor for questions from the audience to both Valérie and Zita. And Valérie, perhaps you can come back to us on video as well. Yeah, here she is. So all you need to do is just let us know that you'd like to take the floor, press and come and make your contribution orally and on video. But you can also do it on chat if you like. So I'll use my prerogative as moderator to give you the first question. We're talking about transformation. In the 60s, when President Kennedy said by the end of this decade we'll go to the moon, they had to invent so many new things to enable our spacecraft to be able to reach the moon. What is that equivalent in the transformation we're talking about here? Do we need to invent new stuff? Do we need to change our political system? Do we need to change our economic system? Is it just a mindset thing? Do we need more investment in some place? So what is that first mover action that you think can take the world more into that climate neutral and resilient state that you aspire to, and that the science is calling for in terms of that transformation? Because in my view, I haven't seen you saying we need to invent a new thing that does that. So it seems to be a much simpler thing, and yet it is quite difficult because it's not happening. So what is the core aspect? What is the core driver of that transformation? So Valérie and Zita, who wants to start?
So if I may, I would like to flag one thing which is important. We are operating in an academic framework. It is the importance of enhancing climate literacy. So understanding the causes, understanding what matters where you live or for your sector of activity, understanding the challenges and the implications, and understanding the options for action. And the IPCC reports, they do not provide a roadmap. They just provide a rigorous and objective way of assessing what are the options for action, for adaptation by sector, for sectors transformations, for reducing greenhouse gas emissions. They show the potential, the feasibility challenges, the costs, but also they highlight the co-benefits for climate action, for instance, improving air quality. And this framework can be used at any context, to develop, in fact, a context-specific smart roadmap. What really is stimulating, I think, is the fact that the assessment of options for mitigation now shows that there are solutions available that could reduce by almost half global greenhouse gas emissions by 2030. So I think the main challenge is how to build on that, how to attract funding so that this can be deployed as fast as needed in a very smart way so that it leaves no one behind.
Very good. So basically, we need a critical mass of awareness and understanding that can lead to incentives and disincentives at policy level to guide us in the wrong direction. It's not really inventing a new technology here, but more an alignment towards where we need to be. Zita?
Yeah, I'm glad to add. I think going to the moon was easier because it's a measurable. It was difficult to find a way to get there, but it was a very measurable one goal. And I think this is the challenge of the climate change related action, that you need to move so many different pieces, and those pieces need to be going in an aligned way into the same overall goal direction to reduce emissions, right? And to adapt to the changes we already committed to. So I think my way would be to define a set of goals, and some of them are indeed provided by the IPCC report, if you do not call them goals, but potential ways to what could help. I think we need to go with a set of goals and then align, so to say. The beauty of the going to the moon thing was that it's aligned business with the government's goal and with science, and they joined up together to develop everything what was needed to go to the moon. And I feel that probably if we are looking at what the European Commission is currently doing with its programming, the European Commission changed its programming to mission-based programming. They selected 5 missions and kind of trying to align resources and attention to those 5 goals. One of them is directly related to climate change, but some others are indirectly related to. So my opinion is we need different missions, and we need to align the respective community to reach those goals.
Yeah, so highlighting that we're in an ultra complex system with so many different players, so many different communities, and it's an exercise in alignment towards a different direction, which in itself is a huge effort. So now I had a question from Karen Thompson, and it's in the chat. To what extent do the models incorporate consideration of the innovation curve?
Do you need to elaborate?
Yes, please, Karen, go ahead.
Okay, well, I expect most people have heard of the innovation curve, but this is the idea that it's most usually illustrated with a lily pad covering a pond. So the pond is only 50% covered at day 29. By day 30, it is 100% covered, because you get that, it's exponential growth. So I just wondered to what extent, I suppose there's 2 parts to this. Firstly, it's the idea of innovation and the technology, and even adoption of existing technology like renewable energy. We're all worrying about how slow that is. But on the other hand, that innovation effect could mean that we won't see very much until almost the last minute, when it's almost too late, perhaps. And I appreciate we're in a very complicated systems, complex systems, and we don't know what individual changes will do. But I suppose the other part to that, and it was mentioned just now, was the idea of critical mass in terms of raising awareness. Will that be subject to the innovation curve? So thank you.
Okay, so you want to take that, Valérie?
Yes. What is really fascinating in the IPCC Working Group 3 report, so on mitigating climate change, is that there's a whole new chapter on the social dimension. And it highlights that in any group, a percentage of people changing practices of 10 to 30% can be enough to trigger and move the rest of the group, to adopt new practices and change. So that's something really important. It also highlights the role of influencers in a way, role models that can inspire further change. And my view of the solution space from working groups 2 and 3 of the IPCC is that there's one dimension that's technologically driven or engineering driven for adaptation. There's one dimension that's based on nature, so thinking differently, and instead of destroying ecosystems, building on restored ecosystems that provide their services. And it's really fascinating, for instance, when you look at the Netherlands and how they think of their relationship with sea level rise, completely thinking differently from Levi's, as the only solution to live with sea level rise, but also working with ecosystems. And the third dimension is the social dimension for adaptation, risk sharing, social safety nets, but for mitigation, the issue of sufficiency. And I would like to place an emphasis on that aspect. So sufficiency, it's, reducing your energy, material, land, water use that allows you to live decently, and everyone, in fact, to live decently within planetary boundaries. So the issue is also, how can it be possible to make it affordable, accessible for everyone, in fact, to adopt a low carbon lifestyle? And it's not just, individual choices. It's making it possible to have active mobilities in cities, and it requires safe infrastructures or public transportations. And so thinking in that way can also lead to different strategies that do not only rely on technology, but also rely on how you transform the way we operate to facilitate also low carbon lifestyles.
Go ahead, Zita.
Karen, just to the aspect of your question around exponential growth, I always think that this pandemic must have been good for something. And I think one aspect is that we have kind of a global learning around exponential growth. So I think for many people, it is really difficult to grasp the concept of exponential growth. And what you mentioned, the pond and the water lily example is such an example. But with COVID, we actually all witnessed how this is working. We have seen them every day in the newspapers, in the media, and watch the curves. And I think that this was so global, and we should harvest those kind of behavior learnings also for climate change adaptation and mitigation purposes, because the learning is still there. I think it will be quickly gone. So I would always try to reconnect this global experience to our behavior changes for the future.
Thank you. And the COVID experience was more
yes,
like...
and maybe...
Yeah.
Oh.
Go ahead, Valerie. It's okay.
Yes, there's something that is really also, I think, quite relevant for the image of the pond. And let me add a frog to the pond.
Yes.
In the Working Group 3 report, it's also highlighted that one way to accelerate shift is leapfrogging. So making the latest technologies, available in a cheap way, especially for those who are in heavy need of basic infrastructures for energy, for transport, etc. So as to do like for telephone lines and ship directly to mobile phones, but also for like battery-powered like vehicles and other examples where there's a potential to completely ramp up by providing the latest smart technology, affordable, so that it also combines with the development needs.
Perfect. And now we move to Ali Aouni.
Yeah, can you hear me well?
Yes.
Okay. Yesterday, actually, it was interesting. I mean, Secretary Guterres was addressing the UN, and he was warning of a looming winter of global discontent. And he was referring to a colder than usual winter, very short supply of energy. Basically, I mean, I think he was referring to natural gas from Russia. And this is interesting because for me, there is also a Northern Hemisphere, by the way, influence, because I think he's referring to Jan going forward, and he's probably even Eurocentric, more Eurocentric than usual. But still, the point remains is that when you talk about winter of global discontent, this means that most governments are going to be forced to get more fossil fuel, right? Because to sort of calm the population. And that's probably not going to change very soon. So again, how would that impact the scenarios we've played? And it might even change what Zita was showing, that the gap of adaptation tends to be skewed when you talk to lower income countries. When we talk about winter of discontent, that's going to be affecting basically rich, high income countries in Europe. And if you want to be more specific, I'm talking about Germany, I'm talking about France in specific. Just want to hear your opinion about this. Thank you.
Great. Who would like to take this on?
I can maybe start. So I think they are kind of short-term and mid-term effects what I'm seeing. So in Germany specific, it's yes, now there's a lot of interest to get fossil fuels somewhere else, to actually make sure that that population comes over the winter without major disruption, including industries. But the impetus for change towards renewables is also there, and it's not lost in conversation. So while I think that there are some rebounds effects, so to say, I really hope that altogether the urgency for the energy transformation is getting highlighted. I do have some concerns if it comes to nuclear plants and nuclear-based energy, because that's seen by many now as a good alternative because of the low carbon footprint. But coming more from the environmental perspective, I would surely hope that we are rather marching towards solar and wind energy on the midterm. Yeah, just from my side, Valérie.
On my side, I would like to frame that sometimes, fossil gas was indicated to be a bridge energy, shifting away from coal to low carbon energy. And maybe this current crisis associated with reduced supply of gas might help phase out gas on the midterm faster. And why do I stress that? Gas is used for the heavy industry that will take time to decarbonize. The current price of gas is leading to serious considerations of efficiency and improved circular economy in some cases. In other cases, gas is used for heating, and there's a push, in particular in Poland or Germany, to shifting much faster to heat pumps, which together with low carbon electricity can provide excellent heating service with a very efficient appliances. So, there's the temporary crisis where coal phase out is slowed. But at the same time, there are major investments underway in the production of heat pumps, the deployment of heat pumps. There are also considerations, of democratic values for some in providers of energy that push very seriously for ramping up the deployment of renewable energy. And in my own country, France, I think this will be the main outcome. There's a law that's being prepared for next week. I don't know the content, but the point is to accelerate the deployment of offshore wind and solar electricity production. And this might be the biggest component of energy transition in the coming decade. And finally, it pushes also governments to consider sufficiency. So playing on the demand side and investments to support a lower carbon lifestyle, which includes, for instance, investments in cycling infrastructures, investments to help reduce consumptions at peak time for electricity. And when we look at this part, the demand side, it's 40 to 70% of the greenhouse gas reduction potential by 2050. And we know we could reach that by about 10% really quickly. So the insights from the current crisis in Europe could, I think, be also informative for other places on how to play on the demand side, on the efficiency side, to ramp up, in fact, some of the transformations.
Very good. Yeah, there's a lot of good indications that we're moving in the right direction, and also indications that we haven't fully migrated from the developmental lens to the existential lens. I mean, we've seen when COVID evidence became visible, we became like the frog that jumped out of the water immediately. But with climate change, at the first glimpse of a recession, it's climate action that suffers very quickly. I suppose because of the long-term aspect of it. It's also the mindset and worldview that hasn't transformed sufficiently. And as we talk about mindset and worldview, I think this is a good segue to hear from Clemens Höppner. Clemens, please go ahead.
Thank you. Basically, my question is, I think from all you said, we have the technical solutions. We could make a transformation happening with what we know nowadays, but it's not happening as fast as it could happen. And then we have this pledge of and I'm from Germany, we have this pledge of the wealthy countries to support the vulnerable countries for a decade now, I believe. It's not happening either. So what do you think, and what needs to happen, what can happen so that we have this global collaboration going on? And for instance, Dr. Riahi presented at Alpbach, European Forum Alpbach 3 weeks ago, and we had a workshop there. And he said he went to the US and he talked about a sharing economy. And he was rejected because just the word sharing economy reminded the people in the US of communism. And they said, no, we can't do that. What are your thoughts? How can we make that happen fast enough, quick enough, so that we really get moving on a global scale? You're mute, Youssef.
Yes, how can we move from an international to a global approach to climate change, where we're all on the same side rather than competing one way or the other? Valérie, Zita?
I think that's the core question. And as you have stressed, it's also about values, about incorporating the urgency of action as a top priority, despite all other shocks and crises that might happen. It's also about having tools to monitor how interconnected we are. And often that approach can be missing. And thinking of, what we can learn from each other. I was struck last summer that in my own country, France, 40,000 people were displaced due to fire weather and the impossibility to control fire, in particular with the record, in fact, heat and drought. But there are lots of insights in other places in the world on how you can manage and build on solidarities within families, within sometimes foreigners that help each other, on how you can cope with displacement at large scale. And so being more open and learning from each other, from different contexts, with different levels of developments and resources, and understanding we can learn from each other, I think is a part of a way to be better connected and work in a way together. Another dimension, which I think is critical, is scientific evidence to relate causes and consequences. And that one for me is related to attribution. So like when there's a disaster, understanding the role of greenhouse gases and human-induced climate change, but also understanding what are the tools for risk management and the immediate and recovery responses that can be implemented at the local scale and help avoid shifting a hazard to a disaster. And at the moment, we still face obstacles to have this full understanding of what can be done on the causes, on the consequences, and the responsibility of the heavy emitters for the losses and damages elsewhere, which also matters to endorse the responsibilities.
Very good parting words. And you, Zita, what do you have to add before we close?
I would bring maybe 3 points. One, I agree with Valérie, we need to continue to provide good science, facts, figures, attribution. But I think that actually we do have a lot of knowledge, and we do not have a knowledge problem here. We have an action problem here. And but my little cartoon meant to say that I think heart and feeling with each other who are impacted and it is really important. And we will be forced to feel it ourselves, so to say. So it's no place is immune. It's everywhere felt, and it's increasing. And the concern is only that if we only act when we are forced to do it, we are losing a lot of opportunities on the way. So it's would be great if we could, so to say, our hearts could be touched. And to end on what Valérie said with loss and damage, I think this will also come much stronger. We are thinking about the flooding in Pakistan, and how strongly this is actually entering the debate, and I think will come at the COP in Egypt very, very strongly forefront. So I think this global responsibility, taking responsibility for each other and feeling what we are doing, I think that's really important.
Thank you very much, Zita. Thank you so much, Valérie. And this is a loss and damage week actually in Bonn, where we have a meeting on the committee in charge with that issue. So these types of messages are very clearly being articulated. What I come out with from this amazing discussion is, number one, the primacy of science. We can't escape it. It is there, and you can look the other way, but it will still be the major determinant of what's happening and what will happen and what we can do and what we can ignore at our own peril. Again, that cooperation is inevitable. There's no way that this can be done through a prioritization of individual interests, national interests at the expense of the rest. It's not going to work. So the notion of collectivity came up very clearly in my mind. We are one world, one humanity, and there is massive interconnectivity of everything that everyone does as it affects everyone else. Sectors are interconnected, even hazards, risks are interconnected, and there's no way we can escape that. It is quite auspicious that the COP session this year will be held in Egypt and Sharm el-Sheikh next November, and of course the American University of Cairo is very active in awareness raising on climate change in Egypt, and so it's a really good opportunity that we had this discussion now on the science. Now the COP is being held this year in the vulnerable continent, the continent of Africa, which also includes the majority of least developed countries, and one of the big elements of discussions in this coming COP session will be that of impacts, vulnerability, and adaptation, and how we can scale up action and support for that, but also ambition in general. We have still to heed the call for transformation that has come from the science. The last COP session has concluded the design of the operating system of the Paris Agreement, and now we're ready to take this further. And a lot of what was said here should be the guiding factors in the direction given to take this further and where the world wants to be and how do we backcast from there. And we've learned how the choices that we make today matter, even though you will wake up tomorrow seeing the same exact day as you saw today, but the choices you actually made might have massive impacts 10 years down the line. So with this, I'd like to thank all participants and the organizers, the Gerhard Center, Aliauni, and of course, our two very prominent experts, Valérie and Zita. Thank you very much and good night to all. Bye.